Hello, this is Jason Kendall, and welcome to my next of my introductory astronomy lectures. Last time we were talking about Kepler's laws and how Kepler discovered that the Earth goes around the Sun in an ellipse as well as all the other planets. Now, Kepler discovered this and published this first in 1609 for his first of his two laws, and in 1619 published the third of his laws, the p squared equals a cubed law, or the harmonic law. So basically, a very, very, very deep opinion, so it's propagating about through Europe, that the Earth, the planets move about the Sun according to Kepler's laws. Well, what we didn't talk about is a particular person that is typically credited with actually having done the whole thing. And he was an incredible figure in all of science and is considered to be the father of science. His name is Galileo Galilei, and he was a scientist, mathematician, public figure from about who was born in 1564 and passed away in 1642. Well, Galileo Galilei, which is basically his first name twice, like me named John, right? So the Galileo Galilei, he actually did an enormous amount of work to try to propagate the idea of the Copernican model of the solar system, meaning specifically the Copernican model, the sun at the center, with all the planets going around on circles on circles around the sun. Now, this was Brahe's, not Brahe's idea. Tycho Brahe had the idea that the sun went around the Earth and Mercury and Venus stayed with the sun and orbited that. That was the Tychonian system. But Kepler used Tycho's data in 1609 to deduce the ellipticity of the orbits. But Galileo received this information in 1609, received it from Kepler and ignored it. Well, because as we learned before, that Kepler's writing was very opaque, and even Kepler himself later in life couldn't actually read it. So it was pretty opaque work. However, we credit Kepler with having discovered the laws, but this happened simultaneously. So let's see what Galileo's story is, because very often people associate Galileo with being excommunicated by the church, and there's an enormous church science battle. And in fact, some of them were the mythology, I'm just going to call it mythology, where the story of science against the church arises. So let's actually see a little bit about what happened, what Galileo said, and where we're going with it. All right, so Galileo espoused the Copernican model because in the 1590s, he considered the nature of the tides, and more specifically, he considered what it meant that if you were in the bottom of a ship, if you were in a ship and the ship was sailing across the sea, and the ship was sailing, let's say, 20 knots under a nice stiff wind, and there were no waves, it was a glassy sea, and you were in the hold, you would not be able to tell, he asserted, that the ship was moving. So since you could not tell that the ship was moving, how would you not tell? Well, okay. If the ship were moving, one of Aristotle's arguments is, if you're in the hold of the ship and you take a ball and you drop it and the ship is moving, then the ship should move out from under the ball and the ball should fall behind you. And you should see an arc inside the ship. Well, we don't see that. What we actually see is that the ball falls straight down. So inside the ship, as the ship is moving, and with no reference to the outside, no way to see the outside, if you take a ball and drop it straight down, it goes straight down inside the ship. It does not fall behind. Things don't accumulate at the back of the boat as they fall or rise or drop. So this was Galileo's idea. And he said, well, wait a second. If the ship is moving, you can't tell it's moving. So if the Earth is moving, then we can think of it as a ship through space. And so therefore, everything would be carried along with it. Now, how does it get carried along with it? Galileo couldn't answer that question, but he posited it from a structure of relativity. And that idea was the one that made him convinced that Copernican model was true. All right. So Galileo was also a man of deep faith, and he was a courtier in the Venetian Senate. He was friends all across Rome and across all of Italy, and he was a very important man. So, but he also was an incredible troll, and he did a lot of things. A troll meaning like internet troll, meaning he really made a lot of people angry with the way he talked, the way he argued, and a lot of things. And part of the reason for his later trial in his life is because he made a lot of people angry. even his friends, for no good reason. So we'll see how that works later. Okay, so basically, when Galileo was convinced that the Copernican model, specifically Copernican, not Kepler's model, but the Copernican model was true, he wanted to make sure that the church followed this idea, because as a man of faith, he wanted his church to be at the vanguard of understanding. He did not want it to be pushed back in time and looked at as something that was behind the times. He wanted his beloved church to have access to the greatest of all knowledge. And so there's a certain sense of humility there. But really he was trying to go after that. So in 1609, he heard about this device being created called a far-seeing look glass. And a far-seeing look glass is basically a telescope. And that's the name that was given to it later. But it was developed in Holland, and Galileo said, wow, he had no idea what they were. But since he knew how to grind lenses, and he was the best one in the area, in Venice, to do that, he basically ground a whole bunch of lenses and created his own telescope. And when he did so, he said, wow, look at this amazing telescope. He went to the Venetian Senate, showed it to them and sold them, and said, this will help you with, he sold it for an exorbitant amount of price. And he also asked for a huge amount of money to actually get it, to use for his goods. And basically, he convinced the Venetian Senate that it was useful for military purposes because you can see ships in the distance, and that it was his, and he should be the one to get money for its discovery. Well, they were convinced. They gave him the money, they gave him position, and then a few days later, a whole boatload of telescopes came in from Holland, and his money was taken away and his position was taken away. Well, this was kind of annoying to him. So he wasn't daunted. He still had the telescope, and he still had thought about the geomobility argument, meaning the Earth moving through space. And he said, okay, fine. Now, I know that Ptolemy could be wrong if I can observe things. So he started looking at the sky, and he utilized his telescope in 1609 to observe things. And the first thing that he did was he looked at the moon. And when he looked at the moon, he saw the moon had valleys and craters and mountains, and it wasn't perfect. Now, perfection is an important element, because remember, in Copernican thinking and Aristotelian thinking is that the heavens and all things of the heavens were perfect by their very nature. If you're in the heavens, you are by definition perfect, and therefore the moon has imperfections. This is a problem. So it's a philosophical argument. The next thing he noticed was that the sun also had imperfections. These are sunspots. He said, well, wait a second, it's not a perfect orb. It has these dark surfaces on it, and that means it also is imperfect. Well, there's another interesting argument. And third, he went further and discovered that when he pointed his telescope at the sky around the Milky Way itself had many more stars visible than can be seen with the naked eye. And so one of the core essences of Scripture was that the purpose of the stars at night was to illuminate us in our day at night. So how do stars illuminate us if we cannot see them and they can only be seen with a telescope? Now, the next one that really got it going was in January 7th of 1610. He pointed his telescope at Jupiter and started making observations of Jupiter. And he found that Jupiter had a series of moons. Well, not moons, other stars. Remember, to everyone, all the planets were stars. They were wandering stars. That's what planetas means. It means wandering star. So he saw that 3 stars wandered right next to Jupiter. They did not have anything that looked like that was fixed with respect to them. There weren't any strings attached. But these 3 stars stayed in a line and went back and forth around Jupiter as Jupiter moved through the sky. And if Jupiter can have satellite stars, then maybe the moon can move with the Earth. Because that was one of the great arguments also against the movement of the Earth, is if the Earth moved, well, then it would leave the moon behind. And since the moon, we knew the moon orbited the Earth, that's been known since antiquity. So if the Earth moved, it would leave the moon behind. And therefore the Earth cannot move because it would leave the moon behind. But Galileo just observed that there are 4 little dots, 4 satellite stars that orbited Jupiter and were not being left behind. So maybe the same can also be true of of Jupiter, of the Earth and the Moon. All right, so this was nearly the clincher for him. But the one that was most important for him was the discovery of the phases of Venus. Now, the phases of Venus were the clincher. In the Copernican model, the phases of Venus can have a full set of phases because Venus can be on the far side of the sun with respect to the Earth. And if it's that way, then you get a full phase for the moon, basically a full phase, just like you get a full phase for the Earth, the moon. You can get a full phase for Venus, but Venus would be very far, so it would be very small. And when it was close to the Earth and very, very bright, it would be in a crescent phase and very large in a telescope. So Venus would have all the phases of the moon if the Copernican model was correct. If the Ptolemaic model, the geocentric model, was correct, where Venus spends its time on an equant between the Earth and the sun, then only new phases and crescent phases and maybe quarter phases could possibly be done by Venus. Now, Galileo observed Venus and discovered full phases. He looked he watched it during 1610 and learned that there were a full set of phases that Venus had. All right. This was an enormous, enormous, enormous undertaking. When he discovered these phases, that fully convinced him that the Ptolemaic model was by definition wrong. So he went off. And so he was so proud of himself that he took these 5 observations of the moon's imperfections, the sun's imperfections, Jupiter's satellite stars, the Milky Way's excessive stars that cannot be seen, and phases of Venus, and put them together in a little book called the Starry Messenger. Now, the Starry Messenger he dedicated to the family of the Medici family, and he named the 4 stars of Jupiter after the sons of the Duke Medici. And so that was to flatter him and get money, and it worked. And he became a sensation all over with the Starry Messenger. And this was his first major argument in favor of Copernicanism. Specifically Copernicanism. Remember, he wrote this book in 1610, which is 1 year after Kepler did his work and published his 2 laws. And Kepler had delivered his laws to it. And people were starting to think Kepler was pretty much on the right track. But Galileo was saying, we got to look at this thing. We have to look at Copernicanism. And Copernicus was right. So on 1610, he published the Starry Messenger, became a sensation, and everybody looked at him. Now, one of the things that Galileo did that became a problem for him was because he was such a man of faith. He used arguments of Scripture to support him, rather than doing a pure scientific idea. And pure science would say, well, here's what we think is a best explanation for the problem, for the observations. And here are the problems with our observations, and here's what we need to solve. What he said is, this is true. And all of his friends in the papacy, in the Vatican, said, you can't really say that. Because if you're going to use Scripture, Scripture is by definition true. So if you're going to use Scripture to support science, Scripture itself says what is true. And Galileo said, but wait a second, wait. There are all sorts of arguments that, and then Scripture said, okay, so Galileo tried to go against Scripture. And it's important to note at this point exactly where in the Bible these things are. And one of the locations is in 1 Chronicles, I think it's 16:30, and there are a number of Psalms, 93:1, I'm reading them off here, 96:10, and 104:5, as well as Ecclesiastes 1:5. But Galileo also used the writings in the book of Job, 9:6 and 26:7, to actually demonstrate that possibly the earth could move. So Galileo was battling Scripture with Scripture. Now, he's a mathematician and a scientist and a lecturer. That's not his job, especially in medieval Europe or Renaissance Europe. The job of interpreting Scripture is for the papacy, is for the Ecclesiastes. It's for the ecclesiastical, not for science. So this was a problem because Galileo was taking, as a lay person, he was taking on the jobs of a priest. Now that was heretical. So in 1616, his writings were deemed heretical partly because of his upstart nature, and he was utilizing Scripture to boost his position. Now, that can be a really, 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 really big problem. So basically, he should have used science as his argument. Fundamentally, though, his main observations were with this telescope and the phases of Venus. So that was what he did. And the rest was trying to utilize people's words against them. So it went on for a while. His writings were to some extent banned. He did some other things later on, and basically he wasn't as in the hole as most people think. He had good friends all throughout the papacy and people who defend him and talk to him. And he was a friend of the Pope. He was a friend of the entire thing. But here's what happened that was critical, that really kind of set the stage for Galileo's rise, for his incredible rise, and his meteoric fall. So in 1623, his good friend, Cardinal Maffeo Barberini, what he did is he was elected Pope. Now, Barberini was a friend and supporter of Galileo's. And what he said was, okay, you can, he gave him permission, or at least seemed to give Galileo permission to write about the nature of the two world orders. This is 1623. This is 4 years after Kepler had delivered his harmonic law, and it was actually quietly making its way around and saying, hey, this seems to be a really good way of actually plotting it, use ellipses. And Copernicanism, by 1623, had been almost thoroughly debunked. I mean, specifically utilizing Copernicus's model of perfect circles with ellipses on ellipses and so forth, in favor of Kepler's model. So people across Europe were quietly using Kepler's model while Galileo was loudly proclaiming Copernicanism. All right. So in 1623, Barberini was elected Pope. Then Galileo said, my gosh, this is my opportunity. I'm going to write this whole thing out. So he wrote a book. And the book was called The Dialogue of Concerning Two World Orders. And it took him until 1632 to publish it. So what he chose to talk about was he tried to actually discuss the dialogue concerning two world orders. What he chose to talk about in this book was to say how the Copernican model met up against the Aristotelian model. Now, at 1632, when it was finally published, Kepler's laws had been out for more than a decade, and yet he makes no mention in this book about elliptical possibilities and geomobility across ellipses. Galileo was really wanted to actually prove this using rhetorical arguments. So in 1632, when he wrote the thing, or actually published it, one of the main arguments is, as I said, was that the curvature of it as you ride along with a vessel, if you drop something in the vessel, it does not fall behind you. So therefore, things can move. And so he had three characters. Three characters in the book were Salviati, which espoused Copernicanism and espoused the ideas that Galileo thought were appropriate. And then you had Salgredo, and Salgredo was a neutral party trying to decide between Earth-centered cosmos, a geocentered universe, and a heliocentered universe. And then to represent the geostationary location and the Aristotelian viewpoint of antiquity that had been around for more than 1,400 years was a character named Simplicio. And Simplicio was an idiot who did not understand any of the arguments. He was written as a dunderhead and a thickhead. So Galileo wrote this as a dialogue between these three people over dinner, over lunch, and it's a magnificent book. It's extraordinarily funny. And when it was being written, and as it was written, it was received quite well, except for the people who held Aristotelian views, because Simplicio was regarded as a complete fool. And basically Galileo attacked a huge number of his scientific colleagues and said, you're basically a bunch of simpletons, you're a bunch of idiots. Now, one of the most important elements that Galileo learned that he had to understand in writing this book was that he was instructed, okay, if you're going to write this, you need to make sure that you give both sides equal time, that the geocentric word gets the last view, and that everything is presented in terms of scientific ideas, meaning you have to show that both ideas, where their flaws and their benefits are. Because the church wasn't interested at the time in really destroying Copernicanism, it was trying to show that if it was going to suppress Copernicanism, it needed to show that it totally understood every aspect of it. So you can't suppress. So this is an interesting viewpoint. So they wanted to demonstrate that they actually understood the Copernican viewpoint. And they were going to utilize Galileo's writing to help demonstrate that. And that's part of the reason why he got the license to write the book and to publish it. But Galileo did everything wrong. He made everybody angry. He pissed off everybody. It gave Copernicanism the last word. He made the Simplicio look like a fool, angered everybody. So in the August of 1632, Galileo was brought on trial for heresy in front of the Inquisition. And there are many of the reasons why. If you look at the actual reasons, none of them were saying like high crimes against this, but mostly it was like, well, you just kind of, there were all sorts of minor things. And in fact, the Inquisition itself said many of these things could be corrected, except for the disobeying part. And part of the disobeying part was that Galileo used Scripture to try to bolster his ideas. And Scripture is truth by definition, because that's what Scripture is for everyone. But science by itself does not describe truths. It describes the best possible explanation for physical phenomena in the real world. So these are the best explanations for the evidence that we have gathered. And Galileo used Scripture instead of science. And that got him in a huge amount of trouble because now he, as a layperson, was up against his beloved church. That was a problem. So Galileo had to recant his, as he went through the trial, it actually spiraled out of control from him. And it could have been fixed. But he chose to resist as he could because he was an arrogant man who was in the habit of insulting people. But it ended up that he had to recant. I don't believe that the story of whether he was shown the instruments and then he recanted. That is most likely apocryphal. But what happened with Galileo was he was instructed not to write about this, not to hold Copernicanism for the rest of his life, and so on. So he lived another 12 years. He died in 1642, but he was under house arrest, and he could not publish data on the world orders for the rest of his life. Now, he was a very smart man, and he actually then decided to write down his arguments on motion. So he started to develop ideas and writings about how things move, how things go down inclined planes, how things fall, how things accelerate. And it's amazing what he did when he finally was forced to just sit in one place and think, rather than go everywhere and tell people what to think and telling people what to do. When he was under house arrest, he actually wrote one of his great books on motions and on how things move. And that book was later used by Newton in order to understand and develop the calculus. So had he not been put under house arrest, Newton would have had to develop even more things. So, well, and there's also an important side note, is that Galileo's daughter, whose story is written about by David Sobel in an amazing book called Galileo's Daughter, Celeste, his daughter, was an incredibly intelligent woman in her own right. And she actually helped edit Galileo's final book. So she lived in Abyss, very close to where her father was being held in house arrest. And it was a very poor abbey. And so she actually helped him write what he was doing, because as time went on, his eyesight was failing. He had extraordinary rheumatism, which he had had even since the 1610s. And so it made it very difficult for him to get around. So he had all sorts of health problems. And so she helped him write this book. So we have Galileo's daughter to thank for her dedication too. And she's an unsung hero of physics and astronomy, and in fact all of science, because she probably helped him through it. And the letters that are extant from between the two of them show that they kept in contact for a very, very long period of time and discussed matters of many, many matters, and both of the faith and of science. So Galileo is credited as being the father of science because he was such an outspoken proponent for ideas that were based on evidence. So he took a telescope and he looked at things rather than using handed down ideas from Aristotle. Now, he tried to then back his data up by using scripture and using people's arguments against him. But really, he actually took the observations himself, interpreted them himself, and then published them himself. That was the main essence of it. So he was an integrated experimentalist and observationalist, experimentalist, and theoretician at once. Now, Kepler took somebody else's data and created an extensive set of theory around it, a mathematical theory, and that's being an astrophysicist. But Galileo, because he was so incredibly loud, brought so much attention to it that even though Copernicanism, with a specific idea of the Copernican model of the cosmos, had been almost thoroughly discredited by 1632, and everyone was quietly using Kepler's laws because they actually worked, nobody actually espoused Copernicanism, and even Galileo didn't know about it, didn't actually acknowledge the existence of Kepler's laws in all his writings. But be that as it may, we consider Galileo the father of science because of the great sacrifice and great effort that he went to in order to make sure that these ideas were known widely. So he actually did fairly little actual observations of the heavens. His eyesight wasn't fantastic, but his contribution with his later writings, as well as Starry Messenger and the dialogue, contributed greatly to the advancement of science and allowed for ideas such as Kepler's, the mathematical ideas, to be smoothed. Because his ideas were quietly rising, but Galileo made a big explosion on the map. And those big explosions everywhere helped shake things up such that ideas based more on observation and logic could flourish. So there we go, is the next thing. And so next time we'll see exactly how Galileo's ideas then propagated forward into the future. See you next time.